enthalpy for this? CH4 plus 3Cl2. Let's say it gives you chloroform plus 3HCl gas. Carbon-hydrogen bond is 413 kilojoules per mole. Chlorine-chlorine bond is 243 kilojoules per mole. That's the amount of energy it takes to make. Carbon Cl, 339 kilojoules per mole. HCl, 427 kilojoules per mole.
Professor,
Yeah.
it's CHCl.
What?
CHCl3. For the third one, you put C to Cl gives you 339. And then CHCl.
What happened?
The third one, he's saying that you put a bond between carbon and chlorine and CH.
You missed.
I missed something?
Yes.
Okay. I put the energy for a carbon-hydrogen bond, yes?
Yeah.
Put the energy for a chlorine-chlorine bond, yes?
Yeah.
Put the energy for a carbon-chlorine bond, yes? Put the energy for a hydrogen-chlorine bond. Which combination did I miss?
No, nothing.
Nothing. I'm just giving you those numbers. Those are the numbers that will be given to you on a table. Okay? All you have to do is use them. Okay? So, now, you have to count how many you have, yes? And which ones are made and which ones are broken. So, for example, which ones are broken on this side? So let's say broken. Which ones are broken?
CH1.
CH4.
CH4. But this is just called a CH bond, yes?
Right.
How many are there?
4.
We're going to say 4. We're going to say we broke them all. So there is 4 of them, yes?
Yeah.
Times the energy is how much?
413.
413 kilojoules per mole. That's going to give you a number. What else did we break here? We broke a ClCl, yes? How many?
Oh, it's about it.
CL2.
3. 3.
3 Cl bonds, yes?
Yes.
Because a Cl2 has 1 Cl bond. ClCl bond, yes? ClCl. How many of these did you break? I broke 3 of them. So 3 times, what's the number?
243.
243 kilojoules per mole. And those are bonds broken. Now bonds made. How many bonds were made? CH. How many did we make of those? 1 CH. What's the bond energy for that? 413 kilojoules per mole. The other one is carbon-chlorine. Yes or no? How many of those do we have? 3 carbon-chlorine bonds. What's the energy for that? 339 kilojoules per mole. What else do we have? HCl bond. How many do we have?
3.
We have 3. What's the energy for that? 427. What?
second one. We don't count the HCl bonds on the first one. The CHCl. We don't count that.
What do you mean
HCl.
CHCl?
No.
Here, this?
Yeah.
No, this H is not on the CL.
It's H and HCl.
Yeah. This carbon
So
has,
we cut it with the carbon, we don't count it with the Cl.
no, it's that the Lewis dot structure is not with the CL, okay? If it's the CL, there's that one over there. That's it, they each make one bond. So guys, tell me what this number is here.
First one, 1652.
First one?
Uh-huh. How much is this?
1652.
1652. And this one?
729.
729. How much is this one?
413. The same?
413. This one?
1070.
How much?
1070.
1017.
Yeah.
And this one?
1281.
You add both of these and you add both of these. How much is this if you add them together?
2381.
2381. What? 2381 what? And this?
2711. Is it just?
So, then the delta H, the enthalpy for this reaction is broken. Just the way it is here, bond's broken, bond's made. So it is 2381 kilojoules minus 2711 kilojoules. These are broken minus made. How much is this?
330. Minus.
How much?
Minus 330.
Minus 330 kilojoules. Is that reaction exothermic or endothermic?
Exothermic.
Exothermic. Okay. Up to where did we get our molecular shapes? We did seesaw.
Yes.
That was the last one?
Yeah.
Yes.
Okay, guys, I'm gonna erase this, okay? So let's do ClF3. ClF3. In order to find the molecular shape or the hybridization or the electron geometry of something, what do we have to do? Lewis dot structure. You cannot do hybridization without the Lewis dot structure. So, Cl. Valence electrons, how many for Cl?
7.
7. There is only one of them, so that's 7. There are 3 fluorines with a valence electron of
7.
7. How much is that?
21.
21 plus 7 is
28.
28. Which one is the central atom?
CL.
Fluorine is the central atom. So I am going to make single bonds to everybody else. And then when I do that, I'm going to fulfill the octet rules for the one outside. So tell me, how many is that?
24. 23 bonds.
24.
24 so far, yes?
Mhm.
I need how many to get to 28?
24.
4 more. I am going to put the other 4 electrons in the central atom. So tell me, what electron geometry does that belong to?
Trigonal plane.
No, 50.
It's trigonal binder.
Somebody smoking something.
Isn't it trigonal?
Trigonal plan.
Okay, guys, we gotta count. 1, yes?
Yeah.
1 electron density. 2, 3, 4, and 5. That's 5. That's not tetrahedral. Tetrahedral is 4. Trigonal planar is 3.
So it's octa.
It's 5. It's not octahedral.
No?
5 is called trigonal bipyramidal. Yes. And this is how it looks, yes? That's how it looks. Yes or no? This is going towards the back. I mean, I could have drawn this like this, yes? Yes, these 3 are in the same plane like that. This is like trigonal planar with something going up and something going down. Yes? Now, if you have, this is called electron geometry, trigonal, pyramidal. Yes or no? So if I had a central atom with how many bonds to it? 1, 2, 3, 4, and 5. With 5, it will be called trigonal bipyramidal. That's the first one we did last week. If I take one of them away, where do I take it from? Do I take it from here?
The center.
No.
I don't take it from there. What do you mean? That's a central atom. Yes, I took a bond from the central atom. And I put an electron pair. Is it like that? Does it look like that? No, it does not look like that. What does it look like? If you put an electron pair, it gets taken off from here. So it looks seesaw. And I thought it was memorable. We said that day, yes? This is, I don't even know how to spell seesaw. How do you spell seesaw? With 2 E's or with 1 E?
Just take out
S-E-E.
Without this? Saw?
I don't know where that extra W came from.
You don't know where it came from? Me neither. Stuff goes on in the head of somebody. Okay? But, so if we're doing this CCl3, I erased it, didn't I? It has 5 things, yes?
Yeah, so it's SPG.
So it looks like that, like this, like that. What do I need to do? I need to now put 2 electron pairs somewhere. Where can they be? You have a question?
I can draw it the other way with just the lines without that dash and that triangle.
Are you asking me or you're telling me that you can draw it?
No, I'm asking.
If you can draw it?
Yeah.
Man. You can draw it whatever way you want, but this is prettier. It is prettier. Not better for you, but it's prettier. So, that one, because this one tells you that one's going to the other side of the room, yes? And this one is coming out of this side of the room. So, it looks like this, yes? But not in this plane. So if you get this and you stand it up, how does it look? Like it has 2 spokes like that, and one coming towards the back, yes? All right, whatever, you draw however you want. So what are we going to do? We have to place 2 electron pairs. Can we place them here?
No.
Why not? Why not? Well, we don't place them here because we will have 90, 90, 93 bonds at a 90 degree, yes? So what it chooses to do is, it chooses to go here, and the other one, since you gotta place 2 of them, chooses to go here. Because they are about 120 bonds, 120 degrees apart from each other. Okay? And they only got 2 90s. So, what is that called? What does that look like?
trigonal.
I mean, if you tell me, I am not looking at this, yes? What does it look like?
A T,
A T. So this is called
T shape.
T-shaped. Outstanding.
Thank you.
How do you like that? That's what it's called. So which one is T-shaped? T-shape belongs to trigonal biparameter. How many electron geometries or electron group domains does it have? 5, but 2 lone pairs. That's called Tshape. Now, of course, it's going to have 3, right? And if it has, what's the hybridization for this? With 5 things. SP3, that's 4, and I need 5. SP3D. You can say SP3D1. Now the next one is, let's look at an example of the next one, XTF2. Fluorine has got 7. How many of them are there? 2. How many does this have?
8.
8 times how many of them?
1.
What's the total here? 22 or 25?
22.
Single bonds to everybody, yes? F. Fulfill the octa rule for those outside. So far, how many do I have? 16. How many do I need to get to 24? I mean 22. 6, yes?
Yeah.
1, 2, 3, 4, 5, 6. Tell me what electron domain does this belong to? 1, 2, 3,
Again.
4,
Trigonal biparameter.
5. It is 5 of them. So this is called trigonal biparameter. That is the group domain or electron domain. 5 of them. This belongs to trigonal biparameter. If it is trigonal biparameter, what is the hybridization of this? It needs 5 things, yes? SP3 would give you 4. SP3D.
The same.
The same as this one, of course. But now the molecular shape does not have this in it. Yes, the molecular shape does not include the electron pairs. So we got to draw something like this. You guys want to draw it like this time? Want to draw it like that? How do you want to draw it? With the dash and the wedge or like that?
With the lines.
What do you mean lines?
Those lines right there, those are lines.
With the swiggly, with the
You
swiggly.
like it like this better?
The swiggly.
I want to make you happy. What way do you guys like it?
It's not pretty, but
It's not prettier, but it's the way you like it. You don't like it pretty, you just like it all messed up.
We want a 3D chalkboard.
Okay, so how many electron pairs do we have to place? 3. This is what it was before, yes? You place another one. Where is it gonna go? It's gonna go here. So if it goes there, you don't see how that looks. I mean, that goes away, that goes away. Well, how does it look? Linear. It looks linear. Very good. Tell me, what are the subdivisions? And of course, you got to memorize some of this stuff. What are the subdivisions of trigonal biparameter? Don't look at them. Just tell me what you remember. Trigonal biparameter. Trigonal biparameter is one of them. Seesaw, T-shape, and linear. What are the subdivisions of tetrahedral? Tetrahedral, or the molecular shapes of electron geometry tetrahedral. They are tetrahedral.
bend.
You're not giving them in order. Why bend first? So you just remember bent for some reason. You like some things that are bent. I don't know what the deal is.
It's an alphabetical order.
No, everybody's looking at it. You defeat the purpose, okay? It's not for you to tell me. I know it, okay? I learned it a couple of semesters ago. It is tetrahedral, trigonal, pyramidal. Yes?
Yeah.
And then bent. What are the subdivisions of linear?
Just
Linear. How about trigonal planar? Trigonal planar and bent and
No, there's nothing else. There's nothing else. There's nothing else, yeah?
Not linear.
Just nothing, just two. It's just two.
All right, let's do octahedral. Isn't this exciting?
Professor, you're gonna ask us to draw the new structure after we allow that it's for you?
To draw the new structure?
Yeah. And right now, they're asking us to draw two structures.
No. I mean, if I give it to you in a multiple choice test, you gotta be able to tell. But no, I'm not gonna ask you to draw this structure. That's F6. How many valence for sulfur? Guys, speak.
7.
Valence for sulfur.
Six.
6, how do you know it's 6?
Because of the group.
Because it's in group 6. Fluorine, how many for fluorine?
7 by 6.
7 plus 6.
7 times 6. It is
42.
42?
Yes.
42.
42.
Yeah.
Sure?
Yes.
How do you know?
6 times 7 is 42. 7 times 7 is 49.
I do
Remember
not-
table from like fourth
I do
grade?
not want you to use your head or your mathematical skills. Punch it in the calculator.
That's common. That's common.
It's common, you learned this when you were in kindergarten, yes? But 7 times 6 is 42, you say?
Yes.
If you add them, how much is it?
40.
You sure?
Yes.
Calculator proof?
Once again, I do not want you to use your head. Is that clear? Some of you on the test will say like 57 or 105. I'm telling you. So 48. Damn, that's a lot, right? F, F, F. How many F's?
6.
Is that 6? 1, 2, 3, 4. Okay, I'm missing one. Is that good?
Yes.
Electrons to everybody outside. Each of those bonds to those, how many do they have? 1, 2, 3, 4, 5, 6 times 8. How much is that?
48.
Once again, you know this because
It's a little dot.
the day of the test when you are very scared, you are not going to remember the multiplication table. You have a calculator, use it. So, how many groups does that have of electrons?
6 groups.
1, 2, 3, 4, 5, and 6. The structure for something that has 6 groups is like this.
I want to see this, bro.
You like it the fancy way or you like it his way?
The swiggly.
You like it fancy. One is going towards the back. This other one is going towards the back too. This one is coming towards the front, and this one down. Or you could just draw it.
The red one.
I don't know which way you want it. It doesn't really make a difference to me. Okay? So, 1, 2, 3, 4, 5, and 6. This looks like what? Tell me, how does that look like?
That's for.
We have been calling these things here before trigonal bipyramidal, or we called it trigonal planar, or we call it trigonal pyramidal. Yes? This is a pyramid with 4 on the bottom, yes or no? But instead of calling it square pyramidal or bipyramidal, we call it octahedral. Okay? Yes? So this is a pyramid on the top with a square base, but we call it octahedral. Like a diamond? Yeah, something like that. So, molecular shape of octahedral geometry is, for this one, octahedral. Yes or no?
Yeah.
What's a hybridization?
It's SP3D2.
SP3, right? I need SP3D5? No, why not? Why not? You're telling me that's not right?
D2, it's not. It's
Why
not
D2?
three, because it's 6. 1, 2, 3, 4, 5,
Oh,
6.
okay. All right. It is D2 because we have 1, 2, 3, 4, 5, and 6, and this is 1 plus 3 is 4 plus 2 is 6. Very nice. The other one is BRF5. Write it, BRF5. Do the electron thing. BRF5. BRF5. How do you want to do this?
Let's do the electron first.
It is 6 times 7. How much is 6 times 7?
42.
Why did you get 67?
What? 6 bonds.
Huh?
It's a 5 pound.
5.
5 by 8.
Hold a second, Louise.
We need
BR is in group 7,
we need
yes?
2 more.
Hold a second. BR is
Yeah,
halogen with 7.
Mm-hmm.
And
Yes.
5 times,
7.
I should say,
7.
7 times 5 is
35.
35 plus this is how many?
42.
That's what we said before, yes?
Yes.
Because they're all halogens, so we
But
can
now
say
it's
6
40,
times
yes.
7.
So we need 2 more.
Okay, whatever.
5
It's
by 8.
1, 2, 3, 4, and 5 times 8 is how much?
40. So we need 2 more.
40.
Yeah, well,
We need 42, we put a lone pair here. Okay? Of course, it has to be that, that's the next electron domain, yes?
So it's 40, and I need 2 more. Got it?
Where am I going to put this electron pair now? If
Anywhere
I
you
put
want.
it here,
On the X.
I'll be 90, 90, everybody 90. Not so good, yes? You can put it on the top or you can put it on the bottom, yes? It doesn't matter where you put it, you can put it on the top. Let's put it on the bottom.
Why? I put it.
Because he says so.
I don't want to say.
Tell us.
He's on the spot.
I don't want to say.
No.
My responses are controlled. So, let's say it goes on the bottom, okay?
Turn it up.
If we take this out, what does that look like? Square on the bottom, yes?
Yeah.
It's a square on the bottom, and then like that.
Yeah.
What does that look like?
Square.
It looks like a pyramid with a square base, yes? So what do you think the proper name for that would be?
Square per.
Square pyramid. Woo. You guys are on fire. You don't need me. Square pyramidal. Hybridization is sp3d2. Next one is xef4.
I have a question.
Uh-huh.
Okay, for this, doesn't it necessarily not matter where you put it? Because if you were to rotate that, it would still look the same. Do you get what I mean? Okay.
It does not look the same.
So if you were to flip it, it would still have the lines going.
Oh, you mean flip the whole thing up? Yeah. What do you mean it doesn't matter where you put it? If you put it here, of course it matters.
No, that's what I mean. If you put it somewhere else, but if you were to rotate the,
Yeah. It's a,
it would look the same.
if I put the electrons here, it's the same, yes? If I put them here, it's the same as that. But I like to put it down here because I can show you a pyramid. You've never seen a pyramid upside down, have you? You ever seen a pyramid like this? like that. You ever seen one like that?
That's pretty
I mean,
cool.
when I went to Egypt on the internet, all the pyramids were like this, yes? That pyramid is under the ground, I've never seen that. So, yes, it is the same if you place it up here, okay?
You gotta go underground.
Yeah, you gotta go on the ground and find out what's inside. I don't wanna get lost in there and that mummy be running after me.
So how was your experience in Egypt and online?
Okay, so subdivisions of octahedral are octahedral and square parameter. The next one is XEF4. What is it? What's XEF4?
And 7 by 4.
Electrons and electrons, yes? So, how many electron groups does this have? 1, 2, 3, 4, 5, and 6. Whenever you have 6 things on a central atom, it is called octahedral. Is the group domain, yes? And it looks like this. Yes or no? Whatever. I had one before, and that was called the square parameter. Now I have two. Where are they gonna go?
Square biparameter.
It's gonna go here now. Now there is no square bipyramidal because square bipyramidal is called the octahedral.
So what is it, square?
Is it square?
This is square?
Yeah, that's right.
Square, okay.
But it is on the same plane, so we call it square
Planar.
plane.
You just have that kind of flat surface.
Yeah, it's flat in the middle and it has like 4 things attached to it.
You got rid of the top bonds and you just had those floating lone pairs. I think that's how they should. Like if you got rid of the covalent bonds at the top and the bottom, it just
Yeah,
left
yeah.
the lone pairs.
Yeah, that's how it looks, yeah. That's how it looks, square, planars. Okay, how's that? That's one of my favorite labs in the lab. I love that stuff.
Making it actually.
Yeah, actually making it, yeah. You take the regular lab, you are VIP. You didn't take the regular lab. But if you want, I'll let you play with molecular models.
Oh, you're talking about the beads that you can make.
Yeah, you make your own models.
I want to buy this.
Can we just
See those by any chance? With a microscope? You can't see.
You can.
You can?
You can. Not with a regular microscope.
Like a scanning electron one?
Yes. Well,
Different, but the same.
there are some structures that you can see how they look. Okay, guys, that's it. But that's not it for today. Don't even try.
Ah, I thought we were going
No,
over.
that's it.
Don't even put the calculator away. That's it for that chapter. Let's do gases. You want gases the real way, you want gases the easy way.
No.
Real
way.
Oh my goodness, you can.
Depends if the easy way.
No, professor, no, professor, give her the real way. Give everybody else the easy way.
Is it like a finger trick but for guessing?
No, it is a trick, but it's not as good as
It's
the
a trick
finger.
trick.
Finger trip is okay. Okay, I am going to begin by spoiling it for you, okay? Spoiler alert. I am going to give you the equation I'm supposed to give you at the end, I'm going to give you now. That's called the ideal gas equation. Ideal gas equation. And it is the ideal gas equation because
what it is.
It's ideal, yes? Is that the real, is that how real gases behave? No, that's why this is called ideal. Like, what you imagine your life is going to be like is ideal. What it really is going to happen is totally the opposite of ideal. So, here's what we're gonna do. We're gonna solve for this thing here, which is, for this R, which is called the gas constant. We're going to solve for that R. So that is going to look like this. PV divided by, hello?
N equals 10 now.
N divided by NT.
Okay. All right. Now I am going to use this, and this is not the way I memorized this when I went to school. I memorized it the long way, and on the test I had to take my cheat sheet out, okay? Oh, erase that from that thing. All right, so here's what we're gonna do. We're going to use this here to find all the laws. PV is what we're going to use divided by NT. Okay? You see it? Now, when I use these two here, the name for this is going to be Boyles Law. So when I use PV, it's called Boyles Law. When I use VT, it's called Charles Law. And this is in alphabetical order so far, yes? The first one is Boyles Law, second is Charles Law, the BC so far. When I use these two, P and T, that's called Gay-Lussac's law. Very complicated, huh? Okay, let's redo this again.
Yeah,
Hold
write
a
it
second.
Yeah, hold on,
So
hold
P times V gives you Boyles Law.
Yeah, yeah, yeah.
P divided by T.
I'm not done, okay? Just understand what I'm trying to do here. PV is called Boyles Law, yes or no?
Yeah.
Whatever is on this side and down here, it's called Charles Law. These two here, of course, the P on the top and the T on the bottom, yes? These two here are called Gay-Lussac's. And then these here, the one here in this corner, and this one down here, it's called Avogadro's law. How does that look like? Like a kite or like an arrow? What does that look like? Looks like this, yes? First one is, guys, first one is Boyles Law. Is that how you spell Boyles? You did? No, I don't believe you.
No, I didn't.
You probably spelled it like this.
Just like that.
Okay, so Boyles Law. Next is Charles. Next is Gay-Lussac. And the next one is Avogadro. Here, the letters here, I messed up on the last one, yes? But hey, I tried. Okay. So, let's now, you already know the laws, let's write them down and see how they look. So I'm going to say PV divided by NT. Boyles Law. Boyles Law says, that the pressure and the volume, guys, you paying attention? She's not paying attention. She's going to ask me what I'm saying just now.
I'm writing.
What are you writing?
Stop.
The pressure time.
Okay? It's important, okay? So look here. Boyles Law says that the pressure and the volume, this looks like PV, yes? PV is equal to a proportionality constant. The pressure and the volume are equal to a proportionality constant. If I solve for P, here what you get is PV is equal to the proportionality constant. yes? So this is if the rest of them are constant. What are the rest of them? N, which is moles.
Number of moles.
This is
Temperature.
temperature. This is
Volume.
volume. And this is pressure.
Outstanding.
Very nice. If they are constant. So which ones are the constant? If N and T are constant. If you change them, then this is not true anymore, right? What that means is pressure and volume are directly proportional or inversely proportional? Inversely proportional. You can look at it here, yes? If this number increases down here, so that means that the volume gets bigger, the pressure gets smaller. Are inversely proportional. You got that so far? Okay, the next one is if I give you gases under one condition and I change those conditions for the same gases, then you gotta be able to calculate the other one. So this is how it looks. You see PV here? PV, 1 and 1 is equal to P2, V2. Under one condition, under another condition. Yes or no?
It's almost like a dilution.
Yeah, it's like the dilution equation, but you gotta use this up here, yes? So, the pressure times the volume for one condition has to be equal to the pressure times the volume of another condition. So let's say that the pressure is 1 atm here, and let's say that the volume is 10 liters. Yes? And what I get is, I get this volume, and I increase it to 20 liters. What did I do to the pressure?
Divide by 20 liters.
That'll be
Everything?
2.
Now you can use your calculator, okay? Don't try to act all smart, multiply 2 times 2 in your head. How much is?
0.5.
.5 ATMs. So what did I do to the volume?
Divided it.
Doubled it.
I doubled the volume. So I increase the volume, what happens to the pressure?
It decreases.
If the volume gets big, pressure gets small. Yes? I increase the volume, the pressure dropped. If I would have made this volume smaller, what happens to the pressure? It goes up. Yes? So if instead I would have put 5 here, what happens to the pressure? So let's say if I double the volume, the pressure decreases by a factor of 2.
Right.
Yes? If I decrease the pressure, or I decrease the volume, what happens to the pressure? If I decrease the volume by a factor of 2, the pressure will go up by a factor of 2.
It's like in a piston like that.
Yeah, that is exactly what's happening in the piston.
Then
Charles. Which one is Charles' law? We did Boyles. Charles is PV. The volume divided by T is equal to a proportionality constant. So volume, if I solve for it, the volume and the temperature are what?
Directly proportional.
They are directly proportional. Volume and temperature are directly proportional. If one increases by a factor of 2, the other one
increase.
Violeta, one increases by a factor of 2, the other one? Huh? Nothing? Oh, you don't see anything is square here? Is anything square? No.
Nothing.
If I put a 2 here, what happens to this here?
You put it to there also?
I put a 2 there. If I put a 2 here, that's a 2 there. Okay,
Right.
because this is a constant.
Right.
So this is 5. Okay. So, if you increase the temperature by a factor of 2, the volume should increase by a factor of
2.
more or less. This only if the pressure and what stays constant?
Number of moles.
And the number of moles are constant.
Only
Now.
if.
How does this look like if I want to use the 1 and the 2 thing? How is this going to look like? V1 divided by V1 divided by T1 is equal to V2 divided by T2. And we will see when we put the numbers what's going to happen. Okay?
This is still part of Charles.
Yeah, this is Charles Law. Okay, I want you guys to do Gay-Lussac's right now by yourself. See if you learned anything. If you can't do it, that's because you don't care about my class. Guys, how much time do we have?
1 minute.
1 minute. Okay, Gay-Lussac. What's Gay-Lussac?
P over T equals a constant.
Proportionality constant.
Yes.
P.
Equals.
That, what does that mean? Pressure on temperature
Or
R?
directly
Directly
proportional.
proportional. Because P1 over T1 equals P2 over T2.
Okay.
That means that the V and the N are constant.
Yes.
Okay. So, yeah, V and N.
We had another constant.
And then now you
So,
do the
P1,
P1 and the
T1.
T1 and equals
And
to
P2
P2.
over T2.
So you get this. And what's Avogadro's?
Avogadro's is, I think it's BV over
It's Vn
MC.
directly proportion if P and T constant.
Avogadro's.
So Avogadro's is?
BV over MC.
No, Avogadro's is not PV over NT. Avogadro's just these two. V over N.
V over N, right? Yeah.
Yes. The one that you said is called combined gas law.
So it's the same if P and T constant, yeah?
Yes. And then this looks like the more moles of a substance you have, the higher the volume, yes?
So it's the same V1 over N1 equals V2 over N2.
Yes. Volume and moles are directly proportional.
Yes.
What's that called? Gay-Lussac's, yes? And V1, N1, V2, N2. Okay, guys, can you turn that thing on?